Now, remainder theorem for numbers. This is one of the most important rules that you must already know. It's very simple to understand also. If there is a number 57 and if I divide it by, let's say, 12. How do I divide by 12? 12 fours is 48. Subtract, I get 9. So what happens? I can write 57 as 12 into 4 plus 9. This is remainder theorem. 57 is the dividend. Okay, usually let's say right now let me present this as n. This 12 is divisor. Let me call it d. This 4 is the quotient. Okay, let's put it as q here. And this 9 is the remainder. Okay, remainder, let's say it is r. So the remainder theorem says any number when it is divided by a divisor, we get some quotient and some remainder, where the remainder, if it is numbers, then remainder has to be less than the divisor, strictly less than divisor, but it can be equal to 0, but it has to be greater than 0. You know, this we have already said that it is always positive. Remainder is always positive, strictly less than the divisor, or 0. Remainder can be 0. This is remainder theorem. You know, how is it useful? If I simply give you an example that a number when divided by 7 leaves remainder 2. What does it mean to you? Leaves remainder 2. What does it mean to you? We can simply say that the number is equal to 7 into some quotient plus the remainder 2. Try to understand that. Okay. There is one simple thing here to understand that, right? So this will be one of the most important tools to solve a lot of questions which are asked in a remainder. Okay. You can directly convert the number into normal form and you can go ahead. But there is another thing. What are the numbers from here? Well, the possible values of numbers you can get by just putting the values of x. If you put x equal to 0, you will get 2. If you put x equal to 1, you will get 7 into 1 plus 2, that is 9. You know, go on adding 7 basically. So 9 plus 7, 16, plus 7, 23, plus 30, plus 7, 37, and so on and so forth. Right? So basically this remainder theorem is not only limited to the questions of remainders, it goes to arithmetic progression and many other cases where counting of numbers is required. So this is a very important expression that you need to remember. The question can be, what is the remainder when n square is divided by 7? Right? So either you simply take one of the numbers and divide, or you can say that n is equal to 7x plus 2. So n square will be equal to 7x plus 2 whole square, and then you simply open it. So it is 49x square plus 2 7s are 14 into 28x plus 4. Now when I divide it by 7, you see the first two parts are divisible, only 4 will be the remainder. Though you don't need to do in this particular question, you could have simply taken 2 square, that is 4. But I'm just saying that, you know, instead of n square, if it was 2n or 3n or 5n or n plus 37 or anything like that, once you have the structure of n, you can solve any such question. Now let's take up the special cases of remainders. The first case is same remainder for different divisors. Question says find largest 3-digit number which leaves remainder 12 when divided by 24, 30 and 40. Right? It's a very simple case. What do we need to understand? That our number n has to be of the form 24x plus 12. It also has to be of the form 30y plus 12. It also has to be of the form 40z plus 12. So one way is we can take out all the numbers, we can get a series here and we can try to identify the common number. But that would be longer. There is a standard process for it. Straight away we say that the number is equal to LCM of divisors, okay, k times, right, plus that same remainder. So in the question in which the remainder is same for different divisors, this is directly what we have to do. So in this case, it is LCM of 24, 30 and 40 k times plus the same remainder 12. Now what is 24, 30 and 40 LCM? 30 and 40, 120, 24, right? So 120k plus 12. So if you can calculate LCM mentally, you could have started from here. So of this structure, we have to find the largest 3-digit number. So the largest 3-digit number will be, you can calculate from this k. If you put 8, 120 into 8, 960 plus 12, and that is equal to 972. Right? Just like this. Fine. So this is the first case of same remainder for different divisors. Okay. Now the second case, case 2, if the difference of divisors and remainders are same, find, let's take an example, find largest 3-digit number which when divided by 7, 8 or 10. So these are our divisors. Okay. Right, leaves a remainder 5, 6 and 8 respectively. Means when you divide by 7, remainder is 5. When you divide by 8, remainder is 6. When you divide by 10, remainder is 8. Fantastic. Do you see that the differences are same in all three cases? 7 minus 5, difference is 2. 8 minus 6. Oh, and the difference also has to be taken in the same direction. D minus R or R minus D. That's okay. But I would always recommend D minus R. So let's fix it as D minus R. Okay. So 7 minus 5 is 2, 8 minus 6 is also 2, 10 minus 8 is also 2. So here it is the same difference case, right? So let's say if the difference is D, then how do we write the answer? We can directly say that the number is equal to LCM of divisors k times, okay, LCM of divisors k times minus that difference. If the difference is same, you could have directly answered this like this. So in this question, the number will be equal to LCM of 7, 8 and 10. Right? What is the LCM of 7, 8 and 10? You can calculate that. 8 5 is 40. 40 into 7 is 280. Minus the difference 2 and k times. So it is 280k minus 2. This is the situation. Right? This is the important part. That you can directly identify the number n like this. Now in this, by putting different values of k, you can get different values of the number. If I put k equal to 1, n will be equal to 278 minus 280 minus 2, that is 278 and so on. But we need the largest 3-digit number. So if I take k equal to 3, I'll get n equal to 840 minus 2, that is 838. If I put k equal to 4, I'll get n equal to 280 into 4. That will become a 4-digit number, right? It is 1120 minus 2, that is 1108. 1118, I'm sorry, it would become, just whatever it is, you can just calculate and check. It is 1118, right? So our answer of the question will be 838 is the largest 3-digit number of this type. Now let's take case 3. The case 3 is that random case in which neither the remainders are same nor the difference of D minus R same. Let's take an example. Find the largest 3-digit number which when divided by 10, 12 or 15 leaves remainder 9, 1 and 4 respectively. Here the remainders are not same. Also the difference, D minus R, if you take 10 minus 9, it is 1. Alright. 12 minus 1, it is 11. Right, and 15 minus 4, that is 11. Oh, two of them are same, but the third one is different. Okay, so maybe we can do it for two of them together and then the third one, but that is not going to be as helpful, right? Let's take the number. The number will be of the structure, you see, either 10x plus 9 or 12x plus 12x ki jagah, let's take a different quotient because we don't know whether the quotient is same or not. 12y plus 1 and 15z plus 4. Can we just write a few numbers here and check if there is any common number? Let's say 10x plus 9, the numbers will be 9, 19, 29 and so on. Okay. 12y plus 1 will be 1, 23, 12, 24 and 1, 25. Okay, wait. It is 25. Okay, 37. Oh, we missed out on one number, 13 and so on. Similarly, 12z plus 4. So it is 4, 19, 34 and so on. Do we have any common number now? No. But up to what number do we need to check? Don't worry. We just need to take LCM of divisors 10, 12 and 15. How much is it? It is 60. Oh, right. So we have to go up to only 60. Don't worry about it. So up to 60 in the first one, we have 39, 49, 59. That's it. Up to 50 in the second one, we have 37, 49, 61, don't take it. 4, 19, 34, 49, 63, no, don't take it. So we have to go only up to these numbers. And check if there is any common number in all of them. Yes, 49 is the first common number. So let's say first common number or first number, right? First number of type n is equal to 49. So how do I write my general number? The number will be equal to same logic, LCM of divisors k times, okay, plus the first number. Just remember this structure. So in this case, our number n is 60k plus 49, right? Okay. Now from this structure, we need to find the largest 3-digit number. Now that is a different thing altogether. Main part was this. Once you have done it, 16, 6 are 960. So 960 plus 49. That is 1009. Be careful. So this is not the answer. So the previous one will be 900 plus 49, and this is 949. So the answer of this question is 949. But yeah, the main thing was identifying these 3 different cases. Now let's take the next case, which says divisor unknown, different dividends and same remainder. Question, let's take an example. Find the largest divisor which gives remainder 4 when divides 214 or 544. Try to understand here the numbers are given. So n is 214, right? Let's assume that the divisor is d and some quotient x plus the remainder is 4. Similarly, 544 is also divisor into some other quotient maybe plus the remainder 4. This is the structure. So from the first one, it is very clear. 4 goes to the other side. 214 minus 4 is 210. That is equal to d into some quotient x. Similarly, in the second case, when 4 goes to the other side, 544 minus 4, that is 540, is equal to d into y. So when you subtract, you don't need to subtract. All right. It is very clear. Can you see that d is a factor of both 210 and 540? Can you see that? D is a factor of 210, D is a factor of 540, right? So D is a common factor of 210 and 540. Also, we need the largest common factor. Why? Because we need largest value of D. Now, what is the largest value? It is called highest common factor, in this case 210 and 540. Find HCF of 210 and 540. It is 30 into 7, 30 into 18, clearly 30. So the required value of D in this case is 30. Let's take another example to make it a little more clear, make remainder theorem a little more clear. Find the largest number which leaves the same remainder when it divides 317, 422 and 597. Try to understand that the numbers are given, divisor is unknown, remainder is also unknown, but the remainder is same, that is very clear. So our first number, that is 31, remember that n is equal to divisor into some quotient plus remainder. In first case, 317 is the number, divisor is unknown, let's say the quotient is x plus the remainder r, right? Second number is 422, that is also divisor into some other quotient plus the remainder is r, right? Then 597, that is divisor into some quotient z plus r. Oh, right. So let's do one thing. Subtract 597 minus 422. You will get, I'll write it, 597 minus 422. And also subtract 422 minus 317. Actually, you could have started from this step. You don't have to write all of this. What will happen? R will get cancelled. 597 minus 422, this R and this R will get cancelled and you will get D common, Z minus Y. Acha. What is 597 minus 422? It is 175. Great. Similarly, 422 minus 317. 422 minus 317. Again, R and R cancel. And D common. So D into Y minus X. The XYZ things are not important. Try to see that. What is important is 175 is a multiple of D, or D is a factor of 175. D is a factor of 105 also. So you could have simply started from these two numbers and you could have said that D is equal to common factor of these two, and we need the largest number, hence highest common factor of these two differences. So highest common factor, HCF of 175 and 105, right? And that is equal to 35 into 5, 35 into 3, so 35. So the value of D in this case is 35, right?